let's look at the science of breaking with the Dancing Turtle.
Hi everybody, this is the Dancing Turtle. I'm Natani, aka Coach Sola. This is...
My name is Tassi.
And I am Coach Checkit.
So we are here today for our third year of Science Fiesta. We are so excited to be here, even virtually. And we are presenting today the science of breaking. So we have our dancers here with us. And we're here and we're super excited to show you all the moves that we have. Here we go.
Let's meet the crew from the Dancing Turtle.
All right, hi everyone, my name is Priscilla. I go by B-Girl P-Love. I've been dancing for about 8 years now and training really hard, and I'm a teacher at E Academy. I teach 8th grade social studies, and the move that I'm going to do today is head spin.
My name is Nicholas Cummings. I go by Glider. I've been dancing for about 6 years now. I go to Amy Beale High School, and today I will be demonstrating crickets.
My name is Ave. I go by Kid Plastic. I go to Amy Beale High School, and I'm going to be demonstrating the three-step. I've been dancing for about 4 years now.
My name is Yuvia, or Big Girl Rain. I go to the Public Academy Performing Arts, and I've been dancing for about 4 years. And the move I'm going to do today is up rocks.
My name is Emma. I go by B-Girl Lana. I've been dancing for about 3 years. I go to Amy Beale High School, and I'll be doing kickouts.
Hello, I'm Lorenzo. I go by Dino. I've been dancing for almost 11 years. I go to Connections Academy, and I'll be doing a variation of the Munch Mill.
Hi, I'm Checkit. I've been dancing for about 29 years. I'm 39 years old, and the move I'm going to do is a one-arm freeze.
Wow, those were some pretty amazing moves. Since this is the science of breaking, let's look at some of the science behind what's happening. Let's start out with Coach Checkit. He's doing a one-arm freeze. So let's freeze him there and see what's happening when he's balancing on one arm. When we're looking at balance, one important scientific principle to consider is center of gravity. The center of gravity is the point in an object in which you have to have it supported or it'll fall over. So for Coach Checkit, if he puts his leg out further or he puts his arm out, he's changing where his center of gravity is, and he'll have to adjust so that it keeps it over his hand so that he doesn't fall over. Similarly, with P-Love doing her head spins or Glider doing his crickets, they have to make sure that their center of gravity is over what's supporting them. So let's look at something else that our breakers are taking advantage of, and that is Newton's third law of motion. So Newton's third law tells us that for every action, there's an equal and opposite reaction. And so let's see what that means for Tassi and Ave here. They're sitting on some skateboards, and when they push off, we see that Tassi goes much further than Ave. This is because Ave is much bigger, more massive than Tassi. So when she pushes, to make the forces the same, Tassi's going to move much faster going away. Now let's look at what happened if we make them the same weight. We've added some weights to Tassi's skateboard, and so now when they push away, they both move away the same amount. So what does this mean for our breakers? Well, they're pushing against the Earth, but the Earth is so big, so massive, that it's not moving, but they're being pushed away from it. The next force we'll look at is friction. So friction is the force that when two things try to slide by each other, it tries to prevent it. So our dancers have to take advantage of that. Sometimes they want their feet to slide, sometimes they don't. As Lana Rain and Kid Plastic do their moves, notice when they want their feet to slide and when they want them to stick. One way that they can control it is by pushing down harder or softer. So the harder they push down on their feet, the harder it is for their feet to slide. If they're a little bit lighter on their feet, it makes it a lot easier for their feet to slide or other parts to slide around. The last thing we'll look at is angular momentum. Angular momentum deals with two different things: how fast something is spinning and how the weight is distributed on it. So here, notice Glider. He's on a turntable and spinning around, and as he moves the weight out, it slows down his spin. When he moves the weight in closer to the center of spin, it makes it go faster. And so this is how breakers can control their spin, by adjusting where their weight is distributed as they're spinning. So let's put it all together. As we watch our breakers, let's notice how they control their balance by adjusting their center of gravity, how they take advantage of equal and opposite forces, when they try to increase or decrease friction, and as they spin, how they control it. Thanks for watching, and keep trying to discover the science in everything around us.